Okay, I'm testing out my OBS screencaster here, and I have an Immerse to Learn Mastercam 2D project here. I'm going to go to top view, and I'm going to turn on my crosshairs there. I'd have to look it up if we had to draw this or we imported this, but this is really just a little demo on how to test this screencaster out. And how would we program this? I've actually programmed this once. Up here I have my own post processor, STC has TMP1, 3-axis. I did some modifications in my post processor file to spit out the code the way I want. So actually, let's go look at this. Toolpath group 1, 2. Let's see. This would be operation 1 right here. And if I turn all the toolpath on, okay. I believe I don't know if I did my own thing or I followed the instructions in the program. But anyway, this is actually one we were also doing as a hand G-code project. So up here we have, I'm going to turn off all the toolpath here. And I have facing, contour, slot milling. So we consider this like classic milling. Let's go over stock setup. Okay, so you could do stock setup a couple different ways. One is to select all the solids, and it'll give you like a basic size. And I like to have it set up so we can use standard bar stock. And then where are we going to set our zero from? In class, we have been running some of the other tutorial programs, and oops, I think we have a setup from the other side here. So we touch off, and let me just rearrange the planes here. Okay, isometric. There we go. And meaning that we're going to the finish line on the model, not the material. But I kind of recommend, and if you were in a real shop, you would just want to like find the middle or find the corner and top without shifting, because that's the less times you press a button on the machine, the more likely you won't make a mistake. So, but we all got to learn different methods. Okay, so there's my, and I also want to start learning how to use stock model. So I may upgrade this one to that. Okay, I got stock plane as top, rectangular, solid, or wireframe. This is actually, probably I could see it a little bit better that way. So I have enough material on the bottom to hold, a little bit on the top, and enough around the sides. And it ended up being like 3 inches wide. So I got enough material to machine on the sides. Okay, I'm going to right click on isometric view. I like turning on the F9 crosshairs of where the X0, Y0 is, or for plane orientation. And a lot of tips and tricks from other people I picked up over time is this is the grid. This was kind of like a helper to help draw. But I believe if you make the grid really small, like 1 inch, here we go. It becomes like a little plane. So then if I shut off the axes, I can get my plane orientation. So any of these helper things you can use. I like, this kind of goes back to my Smartcam days. I always like this dark blue background color. I always try to, all different kinds of ways, but I think I end up preferring this all the time. Okay, let's go over operations here. I got 3-inch face mill parameters. So we look in there. Actually, if it'll give you little suggestions of what to cut or not cut. But in this case, I like using 1 inch for my clearance approach moves, and everything else would be 100 thousandths. It knows my stock is 10 thousandths on the plus side, so it's already identified that. And our finish line is 0, which would be the top. So I'm just going to do a quickie here and spit out some G code. And normally we would probably be putting that in a USB. Let's see, mil. I always forget where these even go now because I'm always dumping in a USB. We'll just dump it there. So we're going to hit, let's try this again. G1, green check, hit save, already exists, yeah, replace. Post-processors from a previous version of Mastercam needs to be updated. Do you want to, yeah, want to update it. All right. And looks like it updated it. And there we go. Okay. So we have a file. So I actually had it updated. So, well, the file name is going to come because we typed it in there. I had to put in here machine and what machine and the maximum RPM. And we have a date stamp and time. The material would come on your material selection, but I also had to do a tool list right here. I have done other things like doing a manual entry in machine. I'm sorry, toolpath, 2D manual entry right here. And I'm going to do it as a comment. So that, and I could put some other setup information here like G54. Let me put my caps on. X0, Y0 equals upper left. Z0 equals top. Shift XY 0.05. Or well, let's see, Shift X positive 050. Let me put a decimal point in there. Y negative 0.05 and Z minus 0.01. Only, yeah, so I actually want to move this up to here. So I'm going to put it up there. So, all right, so when I do that, G code now, I'm going to redo this, save, overwrite. I don't know what that meant. Oh, it was reloading this one, and right there, up there. So it's not quite up there, but it's close enough. So this would be like a real quickie. I can have a little setup information up here. So enough. I like having enough information that if I didn't have the setup sheet, I can get this job done. I like having no end lines except at the tool change positions, so you can search quickly. And in my comments, let's see, like this one, contour parameters, tool, I copy and paste this down this here. I could probably get more definitive about it. Always have rapid retract on, but if I'm using this a second time here, which means it pops up that end mill comment again, which is fine. I could probably rename it, but I can, if I'm in the code like here, I know this is when it does the next profile. All right, I got my cutter comps in there. I can see all that, 3/16 end mill. And that does all the slot milling and chamfer mill. Okay. Let's do a quick simulation. The quickest way is to use the wavy line. And I have, let's see, display tool, display holder, display rapid moves. Okay. And this is actually color coded by length of operations. Or you can pull this one down and look here. It says, let's see, total time for just under 5 minutes. Okay. And hit the play button, hit play. I would mill on the top, doing the outside, 2 cuts, and then working our way in the inside. And slot milling that, and doing some hole work, and some chamfering. Okay. Sometimes I like some of these, I like to learn about these other settings. That one, the quick verify. I see other people use that a lot. I need to learn how to use that more. All right, let's go with full simulation. Okay. And if you turn on color loop, same thing will appear. Yeah, we got the 4 minutes 40. Hit play. Kind of fast. Let's rewind this. Or you can go one operation at a time. Like go 1 op, 2 ops, 3 ops. So it's not going to go any slower. 4 ops. That's like single blocking now. Yeah, single blocking our way down. And I've gone beyond the shank of the tool here, so probably should have showed as a issue. But anyway, pretty basic programming here, and it leaves enough material. Save as STL. So I guess this is one way of saving a stock model to be used later. I have used that in other things, so but in this one, yeah, I have manual entry up here, and this one has G55 equals upper right, Z0 equals 0.75 from parallel. Let me spell that better. Pink. Okay. And I got to regenerate that one. Okay. And that would be, I don't know what happened to my view sheets. Planes, operation 2. Asymmetric. So now we're upside down on operation 2 work coordinate system. And I have it so that the offset's going to spit out a G55 for second operation, like a 2-vice job. And there's my work coordinate on the corner, so it's unfinished part. And of course, doing setup, I would describe that if we had the stock on, stock setup. Oh, we don't have a stock setup. Maybe this is a good time to use the first operation. See if I can remember how to do this. All right, so I would, let's see, play this to the end, bink, and then, where am I here? View, home, verify, save stock as STL. I'll just put my temp area, save, close this window. Oh. I guess it's still saving. Okay. Close that up, and then let's go to stock setup here. I'm going to use the STL method. Stock plane is really now op 2 on this side. And file. Oh, I gotta look at where did I stick that thing? Oh, I put it in my public directory right there. Open. Here we go. And display. Display. It's not quite lining up here. Let's see what's going on here. Oh, I know why, because it's I got to line it up to where it was originally. There we go. All right. So this would actually be a good way to demo why we cannot use this as our setup. This is a common issue I see all the time in the classroom. Let me go to my stock setup, and it's on solid. Okay. Let me hit the front view. Okay. This is our finished material. And people will come and try to probe this and then either program it off the stock or mathematically try to figure out. I said, remember, the stock has probably been cut on a saw. It's not accurate enough. We need to probe where this is going to be. So let's remove this and use a 1, 2, 3 block, and we can get this plane and that plane. And also, where are we going to sit on? Are we going to sit on the bottom here? Are we going to sit on some parallels right off of this? So if you're doing it off the parallels, you're trying to control this height right here. So you need to know that distance. You have to go in your print and find out what that distance is. And if you probe the bottom of where it's sitting and then shift it up. So I probably should add in a probing routine in here just as a demonstration, because this is always, the second operation is always the hardest one to show. First is really easy because it's raw material. Second, more difficult. Actually, people that have done manual machining seem to have the concept better because they've already squared up the material. So, all right, we're on second side. I've described the stock. I haven't really used stock model, but I have a decent representation of what it's going to be like. So if I do my sim here, there we go. And wait a minute. Let me get out of this one. And we're going to make this one. Here we go. And what happened to everything? There it is. Okay. Hit the play button. So we're cutting the back off, chopping that down, and exposes the holes, right? And then we went around and chamfered the rest. Pretty simple, and probably could have chamfered those too. And 2-minute job. Okay, not bad. So we could spit out that code. See what that one looks like. Well, this is still being called Project 2. Edit selector, change NC file name. So this one should be op2 save. So this one becomes op1. But if I had dragged them all up to here, of course I wouldn't get the separate. I would like to have this like so it was just one program that ran and did both, but we can learn how to get to that level. Okay, so in this case, let's make this its own. Yeah, we get 1002 there, so this one is program number 1001. Good, all right. All right, so we're going to post this. It says op2 now. And yeah, 1002, it uses tool 1 and 4 from the original side, only we're using G55. And it says G56 here, so I'm thinking that work offset number 2 is really G56. let me change that. I could change that a couple different ways. One would be here. Let's make that a number 1. Update all. Okay, yep. Let's try that one. Save, overwrite, yes, and 55. Good. All right. Learn something new every day. And it's running what? 500 inches a minute. Ooh. Let's go look at that. Tool. Rapid. We got 40 inches a minute. Cut parameters. Oh, feed rate between cuts. Feed rate between cuts. Let me go look at that. All right, so it's got starting at X minus, goes X plus, and loops around. Oh. Let me go look at that. I didn't, high-speed loops. This is some settings I had never played with before. Let me recenter this, hit fit, hit ISO, hit fit again, and turn on this toolpath. I think I'm actually overextending. It's probably also why we're, well, whatever. You're just trying to learn here. So I think on this loop it speeds up. Let's take a look at the code again, which I think I shut off. Okay, anyway. Let's repost it again. Save, yes. And, okay, so it goes from, yeah, it does it on the arc moves. And it goes back to 40. All right. That's cool. Actually, that would not work in the TM1. That's maxed at 400. I'm not sure. I think it gave us an alarm before we did that. And chamfering mill. And then the old, I think I want to update my post so it does G53s to get home now. All right, this is kind of old school. Okay. That's a quickie demo on that, so I wanted to test out this recording session. It's 22 minutes, and I'm going to end this here. So thank you, and talk to you later.